You run the test suite and go to sleep. But overnight, a minor UI update pushes to staging, and the whole build breaks. Modern JavaScript frameworks like React and Angular dynamically auto-generate UI elements as the page renders, creating a shifting environment for automation scripts. On the initial load, an element might receive an ID that looks stable, something like Submit Button 849X. But the moment the page refreshes, that alphanumeric string changes. 849X instantly becomes 271Y. If a Selenium script is hard-coded to look for 849X, it hits a dead end. It scans the document object model, finds nothing, and throws an element not found exception, halting the entire suite. Relying on absolute DOM paths guarantees a brittle testing environment that requires constant human intervention to fix broken locators. Resilient automation requires moving away from absolute positional targeting and exact attribute matching. This shift involves using conditional logic to perform partial, flexible evaluations on elements as they appear in the browser. It also requires spatial mapping, locating targets by navigating from stable anchor points when they lack unique identifiers of their own. Treating the DOM as a relational map rather than a rigid text document is the prerequisite for engineering reliable scripts. In many frameworks, IDs randomize their suffix while maintaining a stable, readable prefix for debugging. The starts with function is designed specifically to handle these partially dynamic strings. When evaluating a div with the ID user123temp, the function slices the text to separate the stable root from the dynamic tail. It locks onto the stable prefix, ignoring the rest. The tail can scramble on every refresh, but the anchor remains secure. This allows a single starts with query for user to successfully return matches for user123, username, or user profile. Partial string matching provides the first line of defense against framework-driven UI randomization. Other challenges involve elements with stable but highly generic attributes, such as a page with 50 identical buttons all sharing the class submit. The AND operator allows you to stack multiple criteria to build a precise composite matching profile. For an element to pass an AND evaluation, it must possess every required property simultaneously. If an element has the correct class but is missing the required data attribute, the gate rejects the node. However, strict precision is not always ideal. Elements that change properties based on user interaction, like a toggled menu, require more flexibility. This is the role of the OR operator. The OR operator acts as a safety net. As long as one condition is met, the element is selected, catching it whether the class is active or disabled. Boolean operators provide the control necessary to mandate strictness for generic elements or flexibility for those that alter their state. The most difficult targeting scenarios involve elements that lack unique classes, IDs, or readable text entirely. XPath axes solve this by defining spatial vectors, locating targets based purely on their relationships within the document structure. To use an axis, first locate a stable reference node to act as an anchor point. Our stable element illuminates as the reference node. We map vertical vectors, one tier up to the parent or down to direct children. The ancestor axis shoots straight up to the document root, the descendant axis branching out to capture all nested elements. Vertical axes enable targeting based strictly on structural lineage, allowing you to completely bypass the need for direct attributes. Vertical navigation has limits when dealing with flat UI components, such as a sequence of form fields that share the same parent. We re-establish our reference node and execute lateral movement horizontally. The vector, moving forward, targets the following sibling. Moving backward targets the preceding sibling. The following axis washes over every node rendered after the reference point. The preceding axis sweeps upward to capture earlier elements. Mastering these lateral and sequential vectors means that every element in an application is reachable, provided there is one stable anchor nearby. These concepts combine to create a resilient hybrid locator strategy used by industry professionals. This XPath syntax appears complex, but it functions in two distinct logical steps. The first section is the condition block. This part uses partial matching to secure a stable reference node despite the dynamic ID. The second section is the relational block. From the anchor, the script uses a lateral axis to move to the sibling node and applies a Boolean fallback to identify the button. finding the target even without unique attributes. This anchor and leap method is the definitive technique for writing completely unbreakable automated scripts in any modern web environment. This matrix provides a decision-making heuristic for deploying the correct tool in any scenario. For dynamic, auto-generated IDs, use starts with to anchor the prefix, use and for strict precision with generic elements, and or for elements with fluctuating states. If an element lacks identifying attributes, establish a stable reference node and navigate to it using XPath axes. Ultimately, a spatial mastery of the DOM geography defines the work of a senior automation engineer.